In this question, we have the following scenario. Question says, sketch the region enclosed by the given curves. So one of them is y equals to 4x squared, and the other one is y equals to x squared plus 3. So how do we visualize these two? Let us try our best to graph these. So x squared plus 3, it means that you are shifting the graph 3 units up. You have a parabola, and this is your typical parabola that you know how to graph. So this is x squared plus 3, and down here you have 4x squared. Okay, I'm just trying my best to have the parabola down here, and this is your 4. You have your 4x squared. So we're interested in calculating this area bounded between these two curves. Is it easier to write everything in terms of x, or is it easier to write everything in terms of y? So first of all, we need to find the boundaries for x, right? X is bounded between what values? What is A? What is B? It means that we need to find the intersecting point between these two. So we're going to do a little bit of algebra here. To find these two, we're going to set these two functions equal to each other. So let us begin. X squared plus 3 is equal to 4x squared, or you can bring everything to one side. 4x squared minus x squared, while here is equal to 3, if it's easier to solve it this way. So x squared becomes 1, or x is plus minus 1. So it seems like my x is bounded between -1 and 1. Well, I found a and b. Now I can just move on and calculate the definite integral, right? The area is the integral -1 to 1. Well, what is the larger y values? It is x squared plus 3 minus the smaller y value down here, or the ceiling and the floor, for x squared, and then dx. Okay, the calculation, the rest is very easy for you. This is equal to the definite integral, -1 to 1. If you combine these two, you get 3 minus 3x squared dx, or 3x minus x cubed. X ranges between -1 to 1. Let us plug in 1, then plug in -1, and do the algebra. Area is equal to 3 minus 1 minus -3 plus 1. So area is equal to 2 plus 2, or 4. This is the area of the object bounded between these two curves. In this question, we want to know what is the area bounded between y equals to x plus 1, y equals to x minus 1 to the second, x is equal to -1, and x is equal to 2. Well, what is the visualization? How do we visualize this? So let us try our best. So for this guy, you just need to shift this 1 unit to the right-hand side, and this guy, you need to shift it 1 unit upward. These are all transformation of the curves that you saw in pre-calculus. Okay, this is my x-axis, and this is my y-axis. Let's just have it here. Not happy with the line. a little bit better line. Okay. Perfect. So let us begin. I'm going to just shift this 1 unit here and graph my parabola. So this is x minus 1 to the second power, and the other guy is x plus 1. This is my line, okay, which is just right here. So let me continue this a little bit here. So we have a better graph. Then we decide what to do with the rest of it. Okay, when x is equal to 1, you get a 2. So approximately here. Let me connect these. Perfect. So what do we see here? We want to know x is bounded between -1 and 2. This is my -1 and a 2. All right. But is 2 the point of intersection between these two? Well, it doesn't seem like it. So if I set, take a look. I'm not using any technology or anything like that. I'm just trying to see if I do algebra, do I get the exact same point of intersection between these two, or is it something further to the left or to the right? So what I'm going to do, I'm going to set x plus 1 equals to x minus 1 to the second power, or x plus 1 is equal to x squared minus 2x plus 1. So I can get rid of some of the terms like 1 and 1. So I get x squared minus 3x equal to 0. If I factor out x, I get x minus 3 equal to 0. So x is 0, x is 3. So as you can see, one of the intersecting point is here, and the other intersecting point is here, which is 3. So 2 is going to be further here, right? Very good. So now I'm looking for the area bounded between these two, and the area that I have, let me use this, is this area between the parabola and the line. Then the other area between the parabola and the line, and x is equal to 2, is going to be this area on the right hand side. So we are calculating the area of this object by dividing this into two areas and adding them together. So as you can see, on this side, on the left-hand side, you have your ceiling, which is x minus 1 to the second, and your floor is the line, x plus 1. When x is between -1 and 0, and when it's between 0 and 2, you have x plus 1 as the larger y value, and the smaller y value is x minus 1 to the second. Okay, let us set this up and start doing the calculation. The area is. So on the left-hand side, you have -1 to 0. And as you can see, you have x minus 1 to the second minus x plus 1 dx plus the second integral, which is 0 to 2 of x plus 1 minus x minus 1 to the second dx. Very good. So let us start doing the calculation. Move this up a little bit. So this is equal to, for x minus 1 to the second power, you can use u sub. It becomes a third x minus 1 to power 3, and minus x is -1/2 x squared minus 1 is -x, -1 to 0. The same process for the second integral. You get plus x squared divided by 2 plus x minus 1 to the third divided by 3. Let me just erase this guy so I have enough space. This is -1. And my x is now bounded between 0 to 2. So again, remember that the integral of x minus 1 to the second dx, you can use u sub, u is x minus 1, du is dx, and this is basically the integral of u squared du, which is a third u to the third plus c. Now let us plug in the values. So this guy is equal to, if I plug in 0, I get a third, -1 to power 3. This is 0, this is 0, minus, and if I plug in -1, I get a third, -2 to power 3, minus a half, plus 1, plus. Now let us plug in 2. Let's use bracket as well. 4/2 plus 2 minus a third minus, if you plug in 0, you get 0 plus 0 minus -1 to third, which is -1 divided by 3. So you have -1 divided by 3 minus, here you have -8/3, and you have plus a half plus, so here you have 4 minus a third and minus 1/3. So let us try to combine these as much as we can. Here you have -1/3 plus 8/3 minus a half plus 4 minus 2/3, right? So if we combine these together, you have 7/3, 5/3. So you have 5/3 minus a half plus 4. Let me just move this up a little bit so I can see what I'm doing. If we take the common denominator 6, you have 10 minus 3 plus 24. So we get 21 plus 10, or 31, divided by 6. Excellent. So we did all the algebra and did the calculation, but the most important step for you guys is to visualize this, see what's happening, how you can just divide this up into 2, 3, or more pieces so the calculation makes sense. If you just try to subtract these two at the beginning and do the calculation from -1 to 2, well, you get a wrong answer.